Hi, I'm Skwiers-Koballa, Program Manager here at Microsoft, generally focusing on databases and experiences for developers with SQL. I'm here today to talk about Azure SQL and Azure Functions, now with an improved integration through SQL bindings. I'm excited to talk about this because these are two great products for developers. Developers love Azure Functions for its serverless capabilities. You get to bring your own code, whether it's C#, Python, JavaScript, Java, PowerShell. You get to bring your own code, and especially oftentimes shipping it right out of source control through the integration with GitHub and Azure DevOps. Similarly, developers love Azure SQL because it's a strong relational database with graph support. There's a large selection of drivers and SDKs, which means that just about any language you're working with, you can work with Azure SQL. While there's a whole different family of Azure SQL options, there is a serverless option with Azure SQL Database where you pay for what you use. Azure SQL also has integration with GitHub and Azure DevOps, so no matter where your code is going or where it's been, as long as you're bringing it into source control, you've got great deployments. When you integrate Azure SQL and Azure Functions, you can build some really impressive apps. With Azure Functions, you can incorporate functions bindings, bringing in like HTTP requests, blob storage, notifications, even pumping out push signals with SignalR. Maybe you're focused more on data and you want to supercharge your data ingestion for stream analytics by combining Azure Functions and Azure SQL. If you have existing applications, integrating Azure Functions and Azure SQL means that you're able to bring in even more applications into your stack. Now, if you're looking to enrich your data with cognitive services, Azure Functions will allow you to do that. There's so many ways to integrate Azure SQL and Azure Functions to build a better app, but the core of it often comes down to a scenario where you're creating an API on a SQL database. This is really common, yet there's always so many kind of it depends types of questions that you have to answer. How much flexibility do I need to have? How much customization do I need to have? How many endpoints do I need to build? And so you start asking questions around, how do I want to build this API? Oftentimes, Azure Functions is a great product for building APIs, but maybe you want to start with using an API package, like a framework, and putting that on top of your database to automatically expose a set of API endpoints based on the tables. You might lose some flexibility, but this can be a really efficient way to get a bunch of endpoints quickly. Now, on the other hand, if you really need to be able to customize your APIs, you can use the SQL SDKs and drivers directly. You build your code for the app logic, so that's great customization ability, but then you also have to open and close the database connection, handle the queries. There's a lot of code to write there. If you need that level of fine-tuned and fine-grained customization, that's a great option. But with SQL bindings, we can start talking about a middle ground where you gain some efficiencies because SQL bindings is handling the SQL connection for you, and then you're worried about the app logic and exchanging the data within the function objects. I put it in the middle here, not because SQL bindings are the only solution. You can use SQL bindings with Azure Functions that also have the SQL drivers in them, so you can have some functions with really high level of customization, while other functions are more efficient to write because of SQL bindings. But SQL bindings are a great way to quickly create APIs on SQL databases, and that's why I'm super excited that we now have public preview for SQL bindings and Azure Functions for C#, JavaScript, and Python. While SQL bindings bring that kind of efficiency and making those functions easier to build, that doesn't mean that they're not for real enterprise scenarios. SQL bindings on Azure Functions do support managed identity authentication to Azure SQL Database, so you can use specific managed identities to go along with each application. The input and output SQL bindings give you two different data flows. The first one is the input, where you're reading data into the function. It's coming from the database. So you'll have your SQL query results, and they become an object in the function. The output binding, on the other hand, saves data from the function into the database. You'll have an object in the function, and it gets inserted into a SQL table. Let's take a look at what both of these look like in functions, both C# and JavaScript. For the input binding, you do need a few attributes to go with this input binding to set it up. Now, they're not too complex. The first one is going to be the query or the stored procedure that you want to run. Optionally, you can pass parameters into that query. And then last but not least is the connection string. The connection string setting is actually the name of the app setting where your connection string goes. No connection strings in code. That is such a relief to see. Your connection string name will be in app settings, whether you're developing locally or on Azure. But that means that that connection string name can be used again and again in different functions as needed, as long as you put that same connection string name. Let's pose the hypothetical. I'm building a sample API for a product list. I need to pass an API response to my front end that's giving me product IDs and names in an array. I want to build this with input bindings starting with C#. In this code example here, we have a query where that select product ID and name from DBO products means that we're running that query as soon as the function starts to run. The function starts when it gets that HTTP trigger, and from there it runs the query against the connection and SQL connection string app settings and puts that in that SQL result object. The function itself is really, really short because we don't need to manipulate those results at all at this point. If we needed to change the result or correlate it into more data, we could certainly do that before returning it with the OK object result right there. But in this case, if the query result itself is exactly what we want to return, that's what we can do. And it's so quick and simple. Let's take a look at how we would build this in real time in VS Code. Here in VS Code, I have the MS SQL extension installed and the Object Explorer open now, connected to an Azure SQL database. I also have an Azure Functions project started for C#, but I know that I want to return the results from the sales LT product table. If I right-click on this table in the Object Explorer, there's a new menu option for Create Azure Function with SQL Binding. This is going to help me out in building this new Azure function. I'm going to call the function product list, and I will leave the company.function namespace and set the access rights to anonymous. The type of binding we're building right now is that input binding, because we're taking data from Azure SQL into the function. And right before our eyes, VS Code put together this C# function that takes an HTTP trigger, and with the SQL binding that runs a query against the sales LT product table, we'll pass that result back to the user. Before we can test this, we know we need a SQL connection string. So we're going to head over to our local settings file. And in the process of creating that function right from Object Explorer, VS Code set up our connection string for us, minus the password. I'm going to go ahead and put that password in there, and then we'll test out that function. Now that we have our password in our app settings, we can go ahead and hit F5, and this will build our function and fire up the function's runtime locally. Whether you're developing locally or in Azure with functions and SQL bindings, you can still run them and test your SQL bindings. So now we have our product list endpoint exposed, and we can go ahead and test it. So let's send that GET request and make sure we're getting the result back that we expect. And so there's our array of products with the attributes that we have in the table. So those are the columns that correspond to our product table right there in the result. So that is how quick it is to establish an API on top of a table with the SQL bindings. Taking a look back at the JavaScript functions, if we look at JavaScript and input bindings or Python and input bindings, they're a little bit different in that the function definition is split into two parts. The first is the function.json file, and then the second is going to be a script file, either JavaScript or Python. For the function.json file, this is where our bindings definition is. So we'll have the direction for the input binding, as well as the type of binding that it is SQL. The name in this definition is the name of the attribute that's being passed to our script function. So in this case, it's named products, and we have a products parameter going into that function. The command that we're running on our database is just select product ID and name from products, and that's our SQL connection string setting. The script is really short because we're not manipulating the products object at all. We could certainly change things, consolidate, work with the data, add our app logic. That's the great part. But at its core, all we're doing is returning the response body of product right back to a user. It would look just like with our C# option. Now, I did want to mix things up a little bit with JavaScript, because for input bindings, you can build a lot of APIs, but those APIs are serving something. They're oftentimes serving some kind of application, a mobile app, a front end. And so in this case, we're going to take a look at JavaScript input bindings when they're correlated with a front end, in this case with Azure Static Web Apps. We have a static web app that is a React app with two services that it's calling. It is looking for a list of categories from the Contoso store, as well as a list of products. But in this case, the product call that it's making also has a query string on it. Kind of makes us think that it's trying to filter by that category ID. And we need to build the APIs to go along with this. We know that Azure Static Web Apps integrate great with Azure Functions. But in this case, we're also able to pull in SQL bindings to the Azure Functions to make our APIs all that much easier. So the category list is just like we saw earlier in the function JSON. We've got a query set as the command text, and then the function itself just passes categories back. Now the product list is a little bit different, because in this case, now we're using parameters where the query string for category ID is being placed in a parameter and then used in the command text. So we are filtering where the sale end date is null, so we're still selling these products, and the parent category is category ID. With these two APIs, we're able to light up our front end with data right from our database. So if I start up our, let me clean up that terminal, make it easier to see. If we fire up the Static Web Apps emulator with our APIs and our React app, we're going to be able to see what this front end looks like with SQL bindings passing it data. So in this case, we have our Contoso Adventure products portal, all lit up by SQL bindings. We have our list of categories down here. And if we select a category, we get that list of products to go along with it. So if we search for components, we get a bunch of bike parts. If we search for accessories, we get helmets and tires and tubes. So we're able to pass information back and forth between these APIs and our front end. You can see the API calls being made with that category ID query string that's passed back to the function serving the static web app. So this is what input bindings look like when they're feeding right into a front end. You can enrich them with those parameters to really narrow down the data you want to look at. That's enough on input bindings. Let's take a look at output bindings. For output bindings, a reminder that you're taking data out of the function and into the database. So the two things that you need to configure an output binding is just the destination table and the connection string. A lot of the setup comes from setting up the object in the function with the data that you need to go into the database. So that object in function is going to correlate to the table that it's going to in the SQL database. The example that we think of most commonly for APIs and output bindings is you want to send a post body to an API. So you've got some kind of JSON that someone is sending to your API. And you need to be able to parse this to pass it and create, in this case, a new product. If we wanted to create a test product with the color red and a list price of $20, how would we go about this? With output bindings, for example, with JavaScript, we'd have the same two files set up where the function.json has our binding definition. The new product object is something that we need to set up in the function. The command text is the DBO products table, and our connection string is still in SQL connection string. The function is a little bit longer than what we saw before with input bindings because, again, we're populating that object with the data that we want to save to the database. In this case, I'm reading the request body directly into new product. I'm not introducing any app logic into it just yet. If we take this example right over to what the C# output binding looks like, in this case, the table name and the connection string are in that function definition. And we know that we need to set up new product, the object, those attributes, to go ahead and insert that information into the database. We're going to take a look at what that looks like with C# now. So we used C# earlier to create an input binding. Now we're going to create an output binding. Our goal is to be able to send this post request where we're saving that test product right to the database. So if I go into my functions, I have an add product function started. I've added the SQL binding. And it's actually able to take in a collection of products if we'd like. We could go ahead and add multiple products at a time. In this case, we know that we're going to be testing a single product. So I can read in that request body right into my function. And I'm going to convert that string into an object product. We know what our product table looks like. That's the SQL down there at the bottom in the comments. And I've converted this to a more strongly typed class. It's going to allow me a little bit more robustness as we introduce a little bit of app logic here. In this case, as we look at the weight value, I've got people that are going to be sending me the weight in pounds, and I want to be able to convert it to kilograms. The other kinds of things that we can do is if we have default values, such as the modified date is right now, we can go ahead and set this as well. But if I go ahead and put an approximate kilogram conversion in there, I can now set my weight to adjust for the pounds to kilograms conversion. Now when I save product to the database, it'll save the conversion for me. Let me make sure I get my notation correct there. There we go. So we know get it side by side so we'll get it clear as possible. We know we're passing in this information. We also want to save a start date and a modified date, so we're adding that to our object, as well as the weight that we're going to be passed is 12 for 12 pounds, and we want to convert that to kilograms before we save it to the database. Though that is the extent of the app logic that we're doing here. But like we talked about earlier, Azure Functions integrated with Azure SQL is a great opportunity to introduce additional richness to your data. We could be calling out to get sales tax information. We could be introducing cognitive services for AI. There's so many opportunities to use and focus on your app logic and how powerful your app is, since you're not worrying about managing the SQL connectivity. Let's go ahead and hit F5 and fire this up. As I hit F5, it's going to go ahead and build our function, and we'll be able to test it by posting this body to our function. And you might have noticed, if you're eagle-eyed, that the connection string setting we're using here in the output binding is the same as the one that we used in the input binding. So we're able to reuse that connection string in app settings without having to worry about putting our connection string in our code or anything like that. We're able to follow best practices a little bit more easily. Now our functions are ready for us. So let's go ahead and test it. Let's add a new product. And we got a 200 OK. Good news is our weight was converted from 12 pounds to 5.4 kilograms. Now this product just happens to be in the accessories category. So if we go over to our static web app, and I'm going to click back on to accessories, at the bottom we can see the test product that we just added. So in real time we're able to leverage all of our different kinds of bindings. Our input bindings here are feeding this React app, while our output binding was allowing us to insert this data right into our database. One thing that I would be remiss not to mention is, what about that great ability of Azure Functions to build our code, put it in source control, and leverage the great integrations for CI/CD, especially with GitHub for Azure Functions? With SQL, there's something called SQL projects, and for SQL code deployment, it's a fantastic way to use all of your database object code in a way that'll compile to an actual schema model. So locally, you have a copy of all of the object definitions. And with SQL projects, you're able to leverage managed deployments. So what happens is, if you build your SQL project and then deploy it, the difference between the SQL project's schema model and the database that exists is calculated for you. So if a table needs to have a column added, instead of trying to recreate the table all over again, the tooling is smart enough just to add that one column. Well, you don't have to worry about that. You can use SQL projects in VS Code, Azure Data Studio, and Visual Studio. And with GitHub, the SQL action is available that manages both the build and deploy for you. Really quickly, popping back into VS Code, what our SQL project looks like for AdventureWorks, the database, is over here in our files. There's a couple of folders for tables and stored procedures. There's an additional view for database projects that focuses just on the project itself and makes it easier to get to certain actions like build and publish. The other kind of developer delight that SQL projects opens up for us is it really enriches our ability to develop locally. You've been seeing me test and work with Azure Functions right here on my laptop. That's great. But what if I want to work with my database locally? With SQL projects, you can publish to a new container that it sets up for you right off the bat, so you're not worried about, oh, have I connected to production? Am I causing problems there? No, you are a developer. You are working on a development instance. Like I mentioned, with the SQL action for GitHub, my deployment for this static web app and database is a single GitHub action. There's a step for the static web apps deploy. We've got our static web apps API token. It knows where our React app is in the Azure Functions in the API folder. We also have a step that builds and deploys our Azure SQL schema. So if we need to add a new table to AdventureWorks, we can do that right here locally. And then when we put that into source control, when we push our changes, it's going to connect to our Azure SQL database, build our SQL project, and apply those changes. The data stays there, and just the changes to the schema are made. It's fantastic. I'm not going to lie, it is really fantastic. So check it out. If you go to ak.ms/Azure Data Studio-SQL projects, you can find out more about getting started in either Azure Data Studio or VS Code. It is cross-platform along with those, so it's a nice way to really dig into SQL development, especially as you integrate with something as flexible as Azure Functions. Earlier, I talked about how Azure Functions with SQL bindings are ready for enterprise use with managed identity authentication. Just a little bit more detail on that here for you now is that you're looking to secure your database access with managed identity. Instead of using a universal admin account or one of those other terrible ideas that sometimes accidentally happen, what we really encourage to happen is to enable either the system-assigned identity or even create a user-assigned identity to your function app. You could do that right from the Azure portal. And then create a database user in your Azure SQL database just specifically for that function access. That T-SQL down there in the lower left corner would take that identity name and in this case only allow that user ability to read and write data. You're not going to be able to manipulate objects, but you can really focus that user scope down even further to just the specific objects that they should have access to. When we saw the connection string earlier in app settings, it had a user ID and password. This was for a test instance, but ideally you're setting up managed identity authentication and your connection string removes user ID and password and moves to authentication equals Active Directory managed identity. That'll really get you up and running. That is all I have to show for you today with SQL bindings. It is time for you to build with SQL bindings. You can either work now in public preview for C#, JavaScript, Python, so you get to decide what kind of enrichment do you want to do on your database. Do you want to build a new database with SQL projects? Do you want to take an existing database into SQL projects? But you can do that all with SQL bindings for Azure Functions.